In triangle ABC, angle BAC is 50, AC is 18.4 and BC is 15. Find the largest possible area and the smallest possible perimeter of this triangle. Now, as soon as this starts saying largest possible and smallest possible, it starts making me think that there's more than one triangle that fits this description. So I'm starting to think ambiguous case of the sine rule. So draw a triangle. It doesn't really matter what it looks like. Draw any old triangle. So BAC is 50. So this has to be A. Let's say this one's B and this one's C. AC is 18.4 and BC is 15. Now note straight away that we do not have the information to use the cosine rule. It has to be sine rule. So I'm going to try and work out this angle here, and I'll call that alpha. So sine alpha over 18.4 is equal to sine 50 over 15. So let's see what that gives me for alpha. So let's bring in the calculator. Let's just clear a bit of space. So let's just solve, and we'll say that's sine x over 18.4 is equal to sine of 50 over 15, and I'd like to solve that between 0 and 180. So that gives me 110.0 degrees or 70.0 degrees. So I'll say that's 110.0 degrees to one decimal place and 70.0 degrees, correct, to one decimal place. So we could have that this one is 110, and we could have that it's 70. Both fit with the information. So if we look at this angle here, if this one's 110, that means that this one down here would be 20. If it's 70, this one will be 60, because 70 add 50 is 120. We need another 60 to get to 180. So those are the possible triangles that we could get. So area max. Well, we know the formula is a half AB sine C. Let's use these sides that we know. And sine of 60 is definitely bigger than sine of 20. So for the maximum area, we want a half times 15 times 18.4 times the sine of 60. So 0.5 times 15 times 18.4 times the sine of 60, still in degrees, that's all good, so 119.5, so let's say that's 119.5, and that will be in centimetres squared. I'm giving that to 1 dp. Okay, so the perimeter min. Well, we want this length if we're going to work out the perimeter, and it should be fairly clear that if we use 20 degrees here, this length is going to be shorter than it is if we use 60. So what are we going to need to work that out? We're going to need either to use the sine rule again or use the cosine rule. So Let's work it out first. Let's go AB min. So that's going to be the square root of 15 squared, add 18.4 squared, take away 2 times 15 times 18.4 times cos 20 degrees. So we need that. So square root of 15 squared, add 18.4 squared, take away 2 times 15 times 18.4 times the cosine of 20. That gives me 6.69 and so on. And so my perimeter is going to be the 6.69 added to the 15, added to the 18.4. So last answer, add 15, add 18.4, and that's 40.1 centimeters to 1 decimal place.